Welcome to Java Arithmetic by Bolin Development. Today's concept should be familiar to all who have studied arithmetic and will put us on a path to approaching algorithms. After today, you will be able to craft simple algorithms in the Java programming language. As my background involves teaching CS in the state of Texas, I will base this lesson off of the Texas Essential Knowledge and Skills Standards, or TEKS. However, these lessons are great for anyone looking to get started with Java. After today's lesson, learners will be able to demonstrate proficiency in the use of arithmetic operators to create mathematical expressions, including addition, subtraction, multiplication, real division, integer division, and modulus division. Let's take a look at the operators we will cover today. In arithmetic, we have the plus sign, the minus sign, divide, and multiply. Today we're going to be adding a sign right here that you'll see looks like what we know as the percent sign. This is going to be known as modulo. Don't fret. All that this sign means is what's left over after we do division, and we'll cover that in just a second. We'll be using a simple system.out.println statement that will print out numbers just like this inside of our command line. First of all, know that the order of operations, or PEMDAS, that you have learned in math class will apply here as well. Let's start with plus. Used for addition, in Java it's used with integer and real numbers. So let's take a look at what that means. In Java, integers are expressed with the keyword, telling Java that I want a whole number. So right here, I could start out and say I want an integer that equals 2. And I could create another one, we'll just call it b, that I could call 3. Here I've told Java that I want 2 and 3 with no decimals. If I try to put a decimal, you'll notice that I'm going to get an error telling me that I'm using the wrong type and that I need to use double. But for right now, let's just focus on integers. So if I were to use the plus sign in this case, it's really as simple as using these two variables that I've declared, a being 2 and b being 3. I can go ahead and run the program. And I'll see that I get the expected answer of 5. 2 plus 3 equals 5. If I wanted to do this with decimals, as we saw a second ago, I would need to change these data types to double, thus allowing me to add decimals. Here I've added a whole other number in these 0.5s, so I should get the expected answer of 6. We run the program, and we see that I got 6.0, or 6. Right? For purposes of this, I'm going to go ahead and just change these back to integer, and we'll move on to minus. Just as expected, with our plus sign, minus works just like it does in the math classroom, and all I'll need to change here is the sign. Now I'm expecting to subtract 3 from 2, and so I should get a negative 1 here. I run, and I see that, in fact, that is what I get. Division should work by just changing the sign. We're just working with these operators today to understand how these small algorithms work, and later on we'll work with more complex ones. But for right now, I'm expecting to do 2 divided by 3. We get a surprising answer here. Now we know if we were to do this as a real number, say we took 2.5 or 3.5 and changed these back and did division, we know that we don't really get 0. We're going to get a decimal. But remember, because we've told these are integers, this is integer division, meaning I'm dealing this with whole numbers. If I were to change this to a double, telling Java that I'm okay with these numbers being decimal numbers, let's see what we get. You'll notice that the answer changes and I get 0.66 repeating, right? So that's going to be a lot of control that you're going to have to stay on top of with these data types, but you'll get this down through practice in no time. So here we go back to our integers, and we notice we get 0 because it can't give us a whole integer number or a 1, so it just gives us nothing. All right, that leads us to multiplication, which again, we should just be able to change the sign because we've already cast these into variables, and let's see what happens. We get a 6. 2 times 3 is 6. Now on this last one, I told you that modulo is really just division and then getting back what's left over. So here, if I were to do just a division symbol, right, and we know that this is 2, 3, and we're going to get back 0. We kind of understand on an integer level why that happened. We said it can't give us back a whole 1. Well, because it can't do that here, it's not going to be able to do that with modulo either, but it's not going to give us 0. It's going to give us what's left over. And in modulo, that means it's going to give us the number that was divided. So 2 will just come back because we couldn't get a remainder that was a whole number, right? Now, let's see if that behavior changes. Should I change it to a double? We run the program, and we see that we still get 2.0. That's because in modulo, it's only going to return these whole numbers that are left over in the remainder category. A side note, this is oftentimes used to tell if a number is even or not. Let me comment this line out really quickly and show you what I'm talking about. I know that the number 2 is even because for a number to be even, it must be divisible by 2. 2 divided by 2 is 1, right? So here, if I were to take this number a and I were to use modulo and say 2, I should be expecting a 0 here, right? Because 2 will go into 2 one time and there's not going to be anything left over. So a lot of times programmers will use this predetermined behavior to determine if a number is even or odd. Let's take a number that I know is even, say 100, and I could say 100 divided by 2. It's going to go in 50 times and it's going to give me a remainder of 0. That means that programmers can use this predetermined expected behavior to kind of control programs to tell whether a number is even or odd. So they could say something like if 100 modulo 2 equals 0, meaning, in other words, if 100 is even, go ahead and print something out or, commit an action, make something happen in the code. So here I could print out something like the number is even. If in fact that is true, it will run and I will get the number is even. 100 is even. This should be mostly review, with modulo being our lone addition today. Remember, modulo just means what's left over after we've done division. We specify that we are working with integers by using the int keyword, and we specify that we are working with real numbers by using the double or float keywords. Try some independent practice of your own. Write a couple simple algorithms to get to each one of the numbers that is listed on the screen. That means you're going to have 5 algorithms per number, 1 for each sign that we've looked at today. Good luck!